Hello students, how are you? Today let us see the remaining methods of preparation of alkanes. In my previous video I have uploaded the preparations of alkanes by using Woods reaction and I have discussed about the intramolecular Woods reaction. Now let us see the remaining method, that is the from sodium salts of carboxylic acids, that is the decarboxylation and Kolbes electrolysis method. First one is decarboxylation. Decarboxylation means removal of carboxylic acid group. Carboxylic acid, sodium salt of carboxylic acid is reacted with soda lime to get an alkane with one carbon atom less than the parent compound. That is the reaction. We can see here sodium salt of carboxylic acid is reacted with soda lime, NaOH plus CaO, to get an alkane with one carbon atom less. Here in the reactant, how many carbon atoms? R plus COO, R plus one carbon atom, and in the product we have only R number of carbon atoms. The number of carbon atoms present in the alkyl group will be obtained as an alkane, and this COO is eliminated as Na2CO3, RH plus Na2CO3. This is a very simple reaction. If you see CH3, CH2, COO, Na reacted with soda lime, NaOH plus CaO. On heating, just on heating, they will react to give an alkane with one carbon atom less. Here in this is sodium propanoate, 3 carbon compound, and in the product we will have only 2 carbon atoms, CH3 plus Na2CO3. This is a very simple reaction of preparation of alkanes. Now let us see Kolbes electrolysis method. In this, an aqueous solution of sodium salt of carboxylic acid is electrolyzed. Electrolysis is done in an electrolytic cell which consists of an electrolyte and 2 electrodes. Here the electrolyte is aqueous solution of sodium salt of carboxylic acid. Sodium salt of carboxylic acid RCOO Na on electrolysis gives an alkane with even number of carbon atoms. So we have to take here 2 moles of aqueous solution of sodium salt of carboxylic acid. In this molecule the breakage occurs here and here. Very simple reaction. If you break the bonds in between R group and carbon and O and Na, you will get the products. So 2 R groups, here R free radicals are obtained, alkyl free radicals are obtained in this reaction, and those 2 alkyl groups will join together to form an alkane with even number of carbon atoms. So R with R, 2 carbon dioxide molecules, 2 CO2 plus 2 NaOH plus H2. This is the basic reaction. This is the basic reaction. Here we are taking an aqueous solution of carboxylic acid salt solution. Aqueous solution of sodium salt of carboxylic acid. In the aqueous solution means it consists of water also. Okay. So water ionizes to give H plus and OH minus ions in the solution. Right? Now let us see what are the different reactions that occur in the electrolytic cell. We have to see the reactions at anode and cathode. At anode means positive. So here this sodium salt of carboxylic acid will ionize like CH3COO Na, CH3 COO minus plus Na plus. Okay. Here I have taken sodium acetate. 2 sodium acetate molecules will give 2 acetate ions and 2 sodium ions. The negatively charged ions migrate towards the anode. Anode is positive, so the negative ions will migrate towards the anode. So the reactions at anode are CH3, COO minus. Here this bond is broken. This bond we should break. So we get 2 alkyl free radicals, 2 methyl free radicals, 2 carbon dioxide molecules with the evolution of 2 electrons. This is the reaction, and these 2 alkyl free radicals will join together to form an alkane with even number of carbon atoms. Okay, so this alkane and carbon dioxide are eliminated or evolved at anode. This is an important objective question, students. At which electrode the alkane is obtained in the Kolbes electrolysis method, and what is the byproduct at anode in the Kolbes electrolysis method? What is the byproduct? The byproduct is carbon dioxide. And what happens at cathode? At cathode, Na plus ions will migrate towards the cathode. These Na plus ions will combine with the OH minus ions plus OH minus ions to form 2NaOH. 2NaOH, and what happens to these H plus ions? These H plus ions are also positively charged. They also come towards the cathode. 2 H plus ions will take the 2 electrons evolved at anode, 2 electrons, and they will be forming 1 hydrogen molecule. So, sodium hydroxide and hydrogen gas. Hydrogen gas is formed at cathode and carbon dioxide gas is formed at anode in Kolbes electrolysis method. So, this is the reaction. By Kolbes electrolysis, we can prepare alkenes and alkynes also. Okay, students. Now let us see the preparation of alkenes. For the preparation of alkenes, we have to take a dicarboxylic acid. A dicarboxylic acid, sodium salt of dicarboxylic acid. The reaction is same. It will be breaking in between carbon and carboxylic acid group here and here. And the free radical site is generated at both the CH2 groups, and these 2 free radical sites will join together to form an alkene. It is an alkene plus 2 CO2 plus 2 NaOH plus 1 hydrogen. Here, instead of taking 2 molecules like in alkanes, we will take only 1 molecule, and we are getting only 1 molecule of alkene. And in the similar manner, we can take an unsaturated dicarboxylic acid. If we take an unsaturated dicarboxylic acid, what we get, students? Can you predict? We get an alkyne. We get an alkyne. The free radical site is obtained here, and it forms CH triple bond CH plus 2 CO2 plus 2 NaOH plus H2. This is the reaction. So by Kolbes electrolysis method, we can prepare all alkanes, alkenes and alkynes. All should be having even number of carbon atoms. That is the limitation of this reaction. Limitation, we cannot prepare methane. We cannot prepare methane by using this reaction. Methane cannot be prepared by using Kolbes electrolysis reaction. That is also an important objective question. Okay, students. And in this, the intramolecular reaction is preferable over intermolecular reaction. This I have discussed in intramolecular Woods reaction. The same principle is applicable for Kolbes electrolysis also. If an intramolecular and intermolecular reaction is possible, the intramolecular reaction, intramolecular bond formation is more preferable over intermolecular bond formation. Okay students, these are all the methods of preparations of alkanes. Hope you enjoyed the class. Thank you.